two principles that separate junior from senior engineers: open-closed and Liskov substitution. Let me show you why these matter and how they come up in every design interview. Open-closed principle plus Liskov substitution principle. Low-level design, day 3. The open-closed principle says your code should be open for extension, but closed for modification. What does that actually mean? Imagine you have a payment processor. Today it handles credit cards and UPI. Tomorrow, the business wants to add crypto payments. With a well-designed system, you should be able to add crypto by writing a new implementation, not by modifying the existing payment processor code. The key tool here is interfaces. You define a payment processor interface with a process method. Each payment type implements that interface independently. When you need a new payment method, you create a new struct that implements the same interface. Let me show you the difference in code. The bad version uses an if-else chain. If the type is credit, do credit card logic. Else if it is UPI, do UPI logic. Else if it is crypto, do crypto logic. Every time you add a new payment method, you have to modify this function. That is a violation of open-closed. The good version defines a payment processor interface with a process method. Credit card implements it, UPI implements it. When you need to add a wallet payment, you just create a new wallet struct that implements the same interface. You never touch the existing code. This is the strategy pattern, and it emerges directly from the open-closed principle. The Liskov substitution principle says if S is a subtype of T, then objects of type T should be replaceable with objects of type S without breaking the program. In plain English, if your code works with a base type, it should also work with any subtype. Here's the classic example. You have a bird base type with a fly method. Sparrow extends bird, and it can fly. Eagle extends bird, and it can fly. But penguin extends bird, and it cannot fly. If your code calls bird.fly and someone passes in a penguin, it breaks. The penguin violates Liskov because it cannot fulfill the contract that bird promised. The most famous Liskov violation is the square rectangle problem. You have a rectangle class with width and height. Square extends rectangle. But here's the trap. When you call setWidth on a square, it has to set both width and height to keep it a square. That means if someone writes code that sets the width to 5 and height to 10 and expects an area of 50, it breaks when you pass in a square. The square silently changes the height when you set the width. The fix is to not use inheritance here. Instead, define a shape interface with an area method. Rectangle and square both implement shape independently. Neither inherits from the other. Let me give you 3 real-world examples. First, payment processing. This is the strategy pattern straight from open-closed. You define a payment processor interface, and each payment method implements it. Adding a new payment method means adding a new struct, not modifying existing code. Second, collections. In Java, ArrayList and LinkedList both implement the list interface. You can swap one for the other without breaking any code that uses list. That is Liskov compliance. Third, notification systems. You have a notifier interface with email, SMS, push, and Slack implementations. When the business wants WhatsApp notifications, you add a new WhatsApp struct that implements notifier. 0 changes to the dispatch logic. Here are the interview questions you will see. For open-closed, they will ask you to design a discount system. The answer is a discount strategy interface with flat discount and % discount implementations. Adding a coupon discount means a new struct, not modifying existing code. For Liskov, they will ask if square should extend rectangle. The answer is no. Use a shape interface instead. Another common question is whether a read-only list should extend list. The answer is no, because calling add on a read-only list would throw an exception, violating the contract. The pro tip for interviews is to always show the bad version first, then refactor using interfaces. It demonstrates you understand why these principles exist, not just what they are. 5 things to remember. Open-close principle means extend via interfaces. Never modify existing code. Liskov substitution means subtypes must be fully substitutable for their base types. The square rectangle problem is the classic violation. Fix it with interfaces, not inheritance. The strategy pattern emerges when you combine open-closed with Liskov. And in interviews, always show the bad code first, then refactor with interfaces to demonstrate you understand the why.